Too many people that I enjoy watching are live. Thanks, Gemma. Is Andy on or no? I don't know. Let me come online here. Is Andy on today? Maybe Andy was on earlier. How you doing today, Gemma? Good evening, Susan. How are you doing? Oh, he's not live anymore? Okay. That's fair. How's everybody doing today? I hope everybody's doing a wonderful today. Hey, Susan, I'm doing really, really good. I finished around 10:30. All right. All right. At least his internet's working again, so that's good. Susan, I'm doing good. I hope you got my email there for the test. I'm doing great, Gemma. I've been having to put out fires all day today, but I was able to put them all out. Excellent. That's exactly what I hoped to have happen. Like I said, you are not the only one that had to go through that miserable mess. It's still a mess. So, whatever's happening over there, I actually have no idea. But, well, give them the rest of today to hopefully sort it all out, and hopefully everybody can get their extra time back. So, everybody gets to get back to normal then. I think a couple days should be fine. They should have everything solved before then, to be perfectly honest. But I'll monitor the situation. There's a fire in your backyard. Ooh, got a little bonfire there. Ooh, I like those. Maybe cook a little bit on the fire. I don't know, Gemma, if you like doing that. Maybe cook some hot dogs, or maybe cook some marshmallows. Maybe make some s'mores. You know, some chocolate, some graham crackers, and some marshmallows there, Gemma. It's very fun. Gotta love that. That's some classic campfire sort of deals. Hey, Mike. Michael, how you doing? Just making sure that all the stuff here was due tonight is getting extended due date. Yes, that is correct. I would just go down there, Gem, and just make a s'more and then walk back out. Yeah, so it got pushed back, Michael, out to Wednesday. So that's when everything is due. Things are going very well. I hope things are good with you. It's been a little bit of time. Hopefully your spring break went absolutely great. Outside of the 2 days, of course, with my math lab stuff, but you know, like I said, that's not something that you can control. That's not something I can control. That's just something that we have to do. That. You feel like an imposter because you're not doing maths, but hey, I don't care if you're doing maths or not. I don't mind. You ask me whatever. You're as part of this. You're as much of this stream as much as anyone else. If you feel free to ask me whatever you want. You're trying to find a new GPU for your birthday. I don't know what your budget is, Michael, but it hopefully is a big enough budget. I have a 2080 Super in my box, but you know, if you're looking to upgrade even further, then maybe go for those 3000 RTX cards if you can get your hands on them. I know certain models are going to be a little bit more available because they're going to come out with newer types of 3000 series cards, so that may be helpful. But, you know. The British one as well? Yeah, who knows, maybe some people may join you, it's fine. Big if, right? That's okay, Gemma. Look, I'm different too, okay? Currently, you know, look, I'm just different. You know, I got this. I'm the only teacher on this channel right now. Okay, does that count? Maybe I'm one of the very few teachers who streams on this platform. Period. All I do is maths all day on Twitch. Of all the things I do on Twitch, I teach mathematics classes. Heck yeah. I had some mock maths. How do you think you did, Gemma? I hope you did well, at least. You do some that and that. Still actually need that, don't I? I think you did okay. Okay. If you got questions for me, Gemma, for whatever, if I can be of some help, then I'll be more than happy to throw that in your general direction. That is not a problem. You know, I'm willing to help with whatever. Hey, Mazdy. Things are a few things I forgot, but we're rolling all right. Great, great. Hey, Mazdy, how you doing, my friend? I hope you're doing good. I hope you're doing good today, my dude. What is this? A15. Okay. Better update that approach. Just a second. It needs to be, say, where do I need to say that? Straight chillin'? Well, that works, my dude. As long as you're chilling like a villain, that's all that matters, my bro. Absolutely 100%. Sure. Okay, that's fine. Hey, Natty, how you doing today? I hope you're doing good. Good. My weekend was great. Outside of my math lab disaster, which I'm sure everybody's been having a lot of issues with. Hopefully, it's not. It went well. I had to get my sleep schedule back on. Yeah, right. I had to get my sleep schedule back on track, but got that too. Got that done. Okay. You have a great one, Gemma. Take care of yourself. Hopefully, I will see you See you in a couple days, or maybe on Andy's stream. All right, we're almost ready to go here. Let me turn this off. Okay, let's do that. Bam, got it. Yes. Alrighty. Alrighty, ladies and gentlemen, we gotta get started here. It was a little bit past 6 o'clock, but that's perfectly fine. We're probably ready to go, so let's get going. Alright. So, let's do some intros, and let's get started with some important information. Alright, have a good night, Gemma. Take care. Okay, let's get started today. Welcome back, everybody, to Monday. Hopefully, you had a very wonderful and nice spring break. Now, as you have all emailed me here, let's talk about the big elephant in the room here. Once again, and I sent out emails here, but if you haven't read your emails here yet, let's go ahead and talk about it. Of course, that is in reference to my math lab. As the past couple of days, my math lab has either been pretty non-functional or extremely slow to the point where you can't get anything done. All right, in which either case, it is very frustrating. I actually tried to do it live on stream for my first couple of classes, and it was still having issues. So whenever they get that stuff figured out on their end, they're going to get stuff figured out on their end, okay? Again, that's not something that you can control. That's not something I can control. That's the only thing that we can do is hopefully wait, and maybe Pearson will get its act together and get their stuff fixed for whatever they do over there. In any case, though, as a result of that, if you have seen the email or not, as a reminder here, I pushed everything back a couple of days, so now the tests and the homework there for chapters 5 to 8 here are going to be due on Wednesday at 11:59 p.m. Okay, so even if you waited until the last second, you did procrastination station, which I know a lot of you did. Okay, so don't lie to me. But you know, even if you did procrastination station, you still got, hey, let's not lie to ourselves here, right? Did It's like some of you did it in the middle of the week, and some of you like, oh yeah, I'm gonna wait till the last minute and be like, okay, all right, and then of course, then stuff doesn't work the way you want it to. Be like, oh, bummer. In any case, that's still 2 days that you guys missed out on, with sporadic availability, or again, it not working altogether. So of course, that's 2 days that you lost. And of course, I'm not going to penalize you for something like I said you can't control. There's uh there's no question about that. So yeah, don't worry about that. Wednesday. I'm hoping by the end of today they'll have their stuff together, and then you'll have 2 days of which to finish up whatever you need to finish up. So that'll be due then. So I think that'll be okay. Are there any additional questions about that? I hope all of you got my email. I know some of you have had email issues, so I try to send out emails and try to get it through to you guys. So, um, did you guys get my email at least? I want to be sure. Yeah, I just saw it. Okay. I hope everybody who's part of the class here got a chance to look at the email. Okay. And make sure that yeah, I have been monitoring it all day. All right, so I have kept it monitored as much as as I possibly can. So um, I'll continue to monitor it tonight and tomorrow, and then if as it says in the email there, if it still hasn't fixed itself in a couple days, I'll extend it again until it does get fixed, because those days do need to be made up. At least you guys should have the opportunity to finish what you need to finish up. So, um, we'll see what happens there, but that's a Pearson end thing and not a UN thing. So it works. It right now, currently as it stands, my math lab works. I mean, I can access the book and stuff like that, but it's just really, really slow. So I checked their site for their down detector site on Pearson. They said, oh, the connection to this, to Math Excel and stuff like that is degraded, so meaning you lose connection over time and it's really, really slow. So I'm like, okay, fine. It's not working the way it should. It should be up to 100%, but it's not for some reason. So, okay, fine. It is what it is. All right. In any case, we have, let's see here. I believe we finished up section 9.2 last time. We talked about the confidence intervals here. We talked about two types of confidence intervals. Okay, we talked about kind of our regular proportion confidence intervals. We talked about t-distribution confidence intervals last time. All right, so that's what we went ahead and did here in sections 9.1 and 9.2. Today, we're going to be doing the last couple sections here of chapter 9. All right, let's at least give you a little bit of a heads up here. Again, we do end in about a month and a half from now. All right, we do have, after today, we're going to finish up chapter 9 here today. We're going to have 3 more chapters on the table. We'll have chapter 10, chapter 11, and chapter 12. Once we go ahead and finish up those 3 guys, we'll be able to go ahead and move forward with the rest, with the last test, because that'll be over chapters 9, 10, 11, and 12. And we'll also, once we talk about that test, then of course right after that will be the final exam. So we're going to have some time, of course, to talk about the material and whatnot. But we will also talk about not only the last test, but we'll have time to talk about the final exam and possibly do some review with that as well once we get closer to the end of the semester. So we're heading into the home stretch here. If you haven't looked on D2L yet, by the way, I did update the grades there up through the first test, so you should have that already set to go. All right, in terms of your current grades, so you'll see how many points you have on the table so far. So if you haven't checked that out, please go ahead and do so. All right. Are there any questions you guys have? Any questions at all? Any questions? Nope, everything's clear? Perfect. Okay. Want to be sure that everybody's on the same page at the very least. None from you? Okay. All right. So we're going to get into some new material here today. So let's go to the big board here today. We're going to focus on section 9.3 and 9.4. Now, one of the things that's going to be very important for this section, all right, I'm going to point out a couple of things, all right? So I do, let me go to the big board here first, and then I'll point out those couple of things here. Now, the thing that's going to be the most important here in this section, all right, and something that we need to at least understand is that what we need to have happen here is we're going to use we're going to lean on the textbook here for this section. Unfortunately for us here, going to have to do this section here the manual way because we don't have the necessary technology here on the calculator to actually do this section out using like what we did in the past 2 sections. So the past 2 sections we just used a calculator function, boom, 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 entered in the numbers, and then we got stuff done fine, fine and dandy. This section here, we kind of have to work around that, okay? But we're going to go through it step by step here about how to go ahead and I know, I know. There's an unfortunately not so much of a shortcut method here in this case, Natty. So this one here is going to require a little bit of say so here, all right, in order to get this thing accomplished. All right, so we're going to go through this slow. We're going to go through this methodically. That way, everybody's on board in terms of how we have to handle this, and need to be specific about certain things here in order to make sense of it all. Okay, so let's go ahead and take a look here at section 9.3. Now, section 9.3 deals with the last type of distribution that we're going to be dealing with here, and we'll also see in future chapters. That is the chi-squared distribution. Okay, so what is the chi-squared distribution? So this distribution here, this is a distribution made for non-traditional curves. So meaning to say, if we talk about a skewed left or skewed right curve, now we actually have a distribution that we can actually call it. We call it a chi-square distribution that we can actually fit it in with. All right, because so far up to this point, we've been talking about normal distributions, the bell-shaped curve. All right, something that looks pretty common, easy to work with. But a chi-square doesn't follow necessarily that same path. Now, what are some properties regarding a chi-square distribution? Number one, unlike a normal distribution curve, it's not symmetric. So you can't cut it down the middle and get a 50-50 shot. That does not how it works here for a chi-square distribution. So already it's going to be very different in terms of its behavior. One thing that is very common, though, is that the shape of the distribution is going to be dependent on the degrees of freedom. Now, if you remember from previous here, the degrees of freedom here was equal to the sample size minus 1. We talked about that about a week and a half back. But just give you a reminder here, that was the sample size subtracted by 1 was the degrees of freedom. Whatever that's going to be will determine the shape of this particular distribution. All right, as the number of degrees of freedom increases, the chi-square distribution becomes nearly symmetric. Okay, so it becomes nearly symmetric here more and more as we increase the degrees of freedom. So essentially, it's kind of the same thing we talked about before. The higher the higher the sample size here, that means that the more degrees of freedom we're going to have. That means that the more symmetric it's going to be, or at least as close as it's going to be. And values for the chi-squared here that we'll talk about here soon are going to be non-negative. Now, let's not forget exactly what we're looking for here. Okay, what we're looking for here is to construct a confidence interval. Okay, just like we did in the past two sections. All right. However, of course, the interpretation for this confidence interval is very different than the previous two, which we'll expand upon here once we do a little recap with that a little bit later on. But let's take a look on how we can go ahead and build this confidence interval step by step. Okay, now for this particular case here, I think it's going to be a good idea for us to look at an example and do the steps at the same time. Okay, so this is one of those things where I think it's just going to be in our best interest to do that here. And I'm going to kind of show some things off here in order for us to go ahead and get this thing done appropriately. All right. So what we're going to do here first, and I'm going to take out the paint tool as well, but let's take a look here at number 11, all right, in the book here. This is on page 454. And we're going to talk about the pH of rain. All right. So the pH of rain here. The following data represents the pH of rain for a random sample of 12 rain dates in Tucker County, West Virginia. A normal probability plot suggests the data could come from a population that's normally distributed. A box plot indicates that there are no outliers. All right, fine. So from a previous problem here, we found that the sample standard deviation here is 0.319. Construct and interpret a 95% confidence interval for the standard deviation pH of rainwater in Tucker County, West Virginia. Okay, now let's talk about what some of the things that they give you a data set and whatnot. Now we're going to talk about some of the important things here. First of all, in this particular case, unlike the last two cases, the interpretation here is going to revolve around finding the confidence interval for the standard deviation. In the last case, we talked about the population mean for everything. This is the population standard deviation for all rainwater in Tucker County. All right. So that's essentially what this is talking about here. Now, if you're wondering how you get 0.319, essentially you would look at this whole data set here to get the actual standard deviation. So to let you know, let's say I want to come up with 0.319 like it says here in the problem. Let's take out our calculator here for just a moment, and we're going to reconstruct how we can get this 0.319 before we get started with the steps here. Okay, so I'm going to answer this last question here. But first and foremost, let's at least refresh ourselves about how we can get our sample standard deviation here first before anything else, all right, with the data set that we're given here. All right, so for us to do that here, make sure you hit the stat key and go to edit. Okay, we're going to clear out any old lists, so we'll hit clear and enter. All right, we're going to go ahead and put everything into list one. So we'll put all the numbers here in list one. So all right, so we'll go ahead and put all 12 of these values down. All right. And then we're going to go ahead and quit out of here. We'll hit second and quit, second mode to quit. We'll hit the stat key here once again. And remember here, we're going to go to one var stats. Okay, so we're going to go to one var stats right here, the very first option. And again, we don't want a frequency list. We're going to just delete that out. We just want to take a look at list number one. So again, on the old school calculator, if you have an old school calculator that is, then you just want one var stats L1. All right, so that's what you want there. And we're just going to go ahead and go down to calculate here and see what we get. All right, so as you can see here for the standard deviation, you notice this says 0.319. All right, so that's where they got the 0.319 here in this problem, is by doing so. Some problems won't give you the sample standard deviation from the get-go, so the reason why I'm showing you this specifically is not only to give you a friendly reminder, but because this would probably be the first step to go ahead and find out the sample standard deviation in certain problems for the homework and the test. All right, so just want to point that out here so that way everybody's kind of caught up to speed here again about how we went ahead and did that. Really quick here, just for people in chat, go ahead and type in done if you do have what I have on the screen. So let's make sure that everybody's on the same page and they got this same result here. All right. All right. Anybody else having issues or everybody okay? All right. So I'll move forward then. Okay. So we're going to use this idea that S is equal to 0.319. We Gucci? All right. We Gucci indeed. Gucci gang. All right. So there you go. You know, that's all I'm going to do for the next, let's see. Um, hmm. All right. Next 90 minutes. Yeah, next 90 minutes, I'm just going to say Gucci gang over and over. Do it like Mr. Beast did. Like 24 hours. You know, we'll just kind of go with that. I'll just repeat it for like a minute, like Gucci gang, Gucci gang, Gucci gang, Gucci. You're like, oh my god, you probably hate me forever. All right. All right. Now we have to construct and interpret a 95% confidence interval of the standard deviation of pH rainwater. All right. So let's go over the steps here carefully. Let's go ahead and put this together. All right, now that we have a calculator thing. All right. Okay, so let's talk about what we're doing here next. Now, We're going to go over this very carefully so that way, again, everybody's on board with what we're doing here in each example. Step 1. Step 1 says state the sample standard deviation. Now that's already given to us here in the problem, but as we saw in the calculator, we could easily find that. We're going to state it as the book says it here as 0.319. If it's not given to you here in the problem, just go to 4 decimal places like you normally do. State the sample standard deviation that way. Fine. Run with it. It is what it is. All right, so that in this case is S. We're going to come back and use S here a little bit later, all right? But again, it will play a prominent role. Next piece of the puzzle here is state the number of degrees of freedom. And the number of degrees of freedom is equal to n minus 1. Now remember that n here is equal to the sample size. So let me go ahead and state that here. N is the sample size. Okay, so remember that degrees of freedom here, the df here, is equal to n minus 1. Now, according to our chart here, let's go back to our chart for just a moment. We have 1, 2, 3, 4, 5, 6. So we have 12. We have 12 data points. Okay, so we have again, our sample size is 12 times 12 rain dates here in Tucker County. So our n here is going to be 12. All right. So with n equaling 12, that means that degrees of freedom here is going to be 12 minus 1, or 11. Now this will be important here in just a second, but again, we need to go with the idea that we have now a sample standard deviation and we have 11 degrees of freedom with n equaling 12. So this is fine. This is fine. All right. Next. Now the next part here is the biggest part of the problem. So this is the part we're going to go over really, really carefully here, because if we don't have this information here, there's no way we're going to find out anything else into the rest of this problem. So let's take a look on what works. So step number 3 here is we're going to use the confidence level and the degrees of freedom, and we're going to find 2 critical values. So in this case here, we're going to find 2 critical values. All right. And the notation here for the critical values looks very weird, okay? It looks really weird, all right? So the notation here looks like this x squared with this alpha over 2 and this x squared 1 minus alpha over 2. Now this x here is actually the chi in chi squared, okay? So the chi and chi squared is actually what this x guy looking like guy is actually a chi, all right? That's just the Greek letter chi, all right? So that's what it is at the end of the day. Now, probably the most important part here is we need to find 2 of these critical values. However, hey, Shenoi, how's it going, my friend? However, what we do need to go ahead and find here is we first need to state the confidence level. So let's find the confidence level here. So the confidence level that we want is we want a 95% confidence interval. So that's what we're specifically looking for here is 95%. Okay. All right. This is college statistics, my good friend. College stats. So I'm not sure where that would rank in England, but I'm not sure which one that would count as because I'm not too familiar with the difference between GCSE and A level. I'm guessing A level if A level is in the college would be a college equivalent. So I believe GCSE is more of a high school equivalent. It's probably my best guess. So, okay. Now we also have the degrees of freedom here. Degrees of freedom as we just found here. All right, that's fair. So the degrees of freedom here is 11. Now, there is a few parts that we need to go ahead and state here. All right, so let's talk about what parts that we need to state here. Now, I put in 3 very important notes here in this part because there's a lot going on at the same time. The first thing is you don't need to square. This is actually part of the notation here. This squared part here is just part of the notation. All right. Ay, 42%. Oh no. Well, I can certainly help you with other concepts that may be on the GCSE. So, well, once I'm done with my class, of course. So, however, you're more than welcome to sit and listen and at any time. So, or ask questions if you have like a statistics question. Not a problem. Um, all right. So we have a confidence level of 95%, degrees of freedom of 11. So first note is you don't need a square. This is part of the notation here, this squared portion right here. All right. The second portion that is really important here, okay, the second portion that is really important here is this second note. And this talks about this alpha. This alpha here, note this notation here says alpha over 2 and 1 minus alpha over 2. This is actually really important, okay? This is actually really, really important. Oh, okay, if that's a B, then that works. I didn't know 42% would be a B, but now I do. All right, now what does that mean here in this problem? Now let's talk about that here. 1 minus the confidence level. Now, we have 95%, which is 0.95. As a decimal, you all are pretty much aware about that here. 95% can be written as 0.95. So what we're going to be doing here, we're going to take 1 minus 0.95. All right, just like so. Now, if we take 1 minus 0.95, that's going to be 0.05. All right, so that's what we get here in this case. All right. That's going to be what this alpha is in this particular notation here. So what we want to find here is we want to find alpha over 2. All right. So that would be 0.05 divided by 2. All right. And that's going to be 0.025. And then we take 1 minus that alpha over 2. So this notation here, like I said, this notation here actually does have a meaning to it. And this is going to equal, again, 1 minus 0.025. So that's going to equal 0.97 at 0.99. I always get this wrong. 0.975, yeah. 975. All right. Okay. So these are the two things that we're going to be looking at here using, first of all, we're going to use 11 degrees of freedom, and we're going to use both of these values here respectively, 0.025 and 0.975. Now, to be honest, you're probably saying, well, where is this all going? All right, what exactly are we trying to do here? All right, where are these critical values that you're randomly coming up from? Well, this is the part where the manual portion has to come into play. To find these particular critical values, we're going to need to use the back of the book here. Okay, so in this particular case, in problems in the homework, you probably will be given like a little table of which to work with. I'm going to be using the table in the back of the book here. That table can be specifically found on page A-15 or A15. That is where you can find this guy here. Let me see if it is there. It should be because I found stuff in the appendix before. I'm going to go to page A15 here. All right, there it is. Perfect. So you notice it says chi-squared distribution. All right, and notice it has degrees of freedom on the left and these numbers on the very top. Okay. All righty. So let's go to our paint tool here for just a second, and let's find our critical value here. All right. All right. So we have 11 degrees of freedom. Let's go with 11 degrees of freedom and underneath the column of 0.025. So you notice how this is kind of set up here. We have these 5 values here, and then it kind of skips over. So it goes from like 0.9, and then it skips over to 0.1, 0.05, and so on and so forth. All right. You can imagine this table here, and I'm actually going to zoom out here for just a second to kind of showcase the whole table here. You'll notice that this has, again, this has this big gap here. Imagine, if you will, you took this table and kind of cut it in half. So if you take it the 0.9 side on the left, that's kind of the left half of the table. Take the 0.1 side, that's kind of the right half of the table. Okay, so you could take this table and cut it in half. If you take a look at both of these values here, they're going to add it up together. They're going to equal 1. Okay, so another way you know what these two values are is that these two values, no matter alpha over 2, 1 minus alpha over 2, add those two values together, they should always equal 1 here at the end of the day. So 2.5% and 97.5% is equal to 100%, for example, in this case. So I'm going to look underneath let's look underneath 0.025. So this column right here. And let's look underneath 11 degrees of freedom. So here's 11 degrees of freedom right here. This is 11 degrees of freedom. Here's our 0.025 column here. Okay. So here's 0.025. And here's 11 degrees of freedom. Lining this up here, we get 21.920. All right, so that's our first critical value here is 21.920. Okay, so crit value 1 here, we got it. So I'll put it as CV1, crit value number 1. That's fine. 21.920. Perfect. Let's go ahead and find out crit value number 2. We're going to look underneath the 0.975 column, which is right here. All right, and we're going to find 11 degrees of freedom. So according to that, that's going to be 3.816. So 3.816 is going to be our second critical value. So there we go. Okay, good stuff. All right, so we found our two critical values here, again, using the table here in the back of the book, or again, using a table that's provided to you here in the homework problem. Whichever way, that's how we're able to properly use the table here, at least in this case. Okay. All right, before we move forward here, are there any questions about how we went ahead and found both of those critical values? This is incredibly important for this part of the problem, and will dictate pretty much what we're going to be doing next. So I want to be sure everybody's on board about how we went ahead and solved for that there. So it says no. Okay, that's fine. Oh, okay. Natty says hydrate. I'm like, okay, fine. What do I have here? I have a little fruit juice left, actually. So I have some fruit juice, some apple, orange, pineapple. What's in this? What's in this fruit juice? Let me see. Hang on. I got fruit juice and ginger ale. So let's see. There's apple, orange, pineapple, peach, and banana. Oh, okay. And a bit of milk. All right. And some sugar. All right. Good stuff. 3 times the hydrate. Oh my goodness, you guys. Take 1 sip. Take 2 sips here. There we go. Hydrated 3 times. Ba-bam. Got it. Hey, you gotta try something new there, you know? I love the eclectic mix of lots of fruits. It's like you taking shot. Yeah, everybody! How did you know? How did you know they replicated shots? Oh my gosh. Oh my gosh. All right. Many different types of drinks. Love it. All right. Anyway. Okay. Let's take a look here at the next step. Okay. So now that finishes up the very critical step number 3. All right. We're going to move on to step number 4 here, which is going to be the big meat and potatoes step. Okay. So now we're going to take a lot of these numbers here. We're going to now put them all together. All right. Okay. Let's go to step number 4. So this is something that definitely needs to be written down. All right, so make sure you have this part written down for sure. All right. Step 4. Using the following formulas, find the lower bound and upper bound of your confidence interval. All right. Okay, so what we're going to do here is we're going to take these two formulas here. We're going to take n minus 1 times s squared, right? That's the sample standard deviation, and the sample size there, minus 1, and we'll divide it by one of our critical values, and we'll divide it by the second critical value. So we got two things going on here. Let's go ahead and take a look at both. First of all, let's write down our big guys here. N was equal to 12 is from before here. Our sample standard deviation that we found here from step 1, once again, as a reminder here, is 0.319. Again, that was from what we found here in step 1. So again, just as a nice little handy reference for you. You don't have to write this out again if you don't want to. Again, I'm just writing it out for the sake of the example here, just to kind of showcase where you have to reference stuff from. And we have our two critical values up here, so I'm not going to rewrite those. But what I am going to rewrite here is I'm going to write down both of our lower bound and upper bound. We have 12 minus 1 times 0.319 squared. Now, the reason why I wrote it as critical value 1, critical value 2 is you could use the notation here. All right, so you can use the notation that we had from before. So this notation you see here, this chi-squared alpha over 2. The problem with using the notation, in my opinion, is it's really easy to make a mistake by squaring what's on the denominator there. So I kind of tend to leave it off because people think, oh, look, it's squared, so you got to square it. Like, no, you don't have to square it. You just kind of leave it alone as is. So it's actually pretty deceptive. So I just want to state it as like critical value 1, critical value 2. And again, I don't have to think about it, so it's a lot easier that way. So here we're going to take 21.920. All right, we're going to get a value for this. Extend this canvas out a bit. All right, and we're going to do the same thing for the next one as well. We're going to take 12 minus 1 times 0.319 quantity squared. We'll divide that by the second critical value here of 3.816. So let's take out the calculator here once again, and let's see what we get. All right. So 12 minus 1, pretty easy. That's 11. So we'll take 11 times 0.319 squared. And we're going to go ahead and divide that by 21.920. All right. Okay. Now I am going to point out one thing here for you guys, okay? One very important thing, by the way, in this problem. Note the answer that we just got here after dividing out by this 21.920 stuff. All right, so we get this pretty long decimal that you can see here on screen. All right, now this decimal here, we are not going to round. We're going to write down the entirety of this decimal here, okay? So we want to reference back to this here once we get to this last step. So we get 510.661953. Okay, so 0.0510661953 is what we get here for the first one. And now we rinse and repeat the process here once again for the second one. Okay, so we have 3.816. Okay, go ahead and check that out here. So here we get point 29333 62159. So the question is, why am I writing this out completely? Why don't I round at this stage? This looks to be like this looks right. It looks like it should be my confidence interval. We actually have to do one more thing here. One very subtle but very important thing in order to actually get our full confidence interval here for this particular problem. Let's take a look at that. So the final thing that we have to do here is step number 5. Step number 5 says we have to take the square root of each number to construct the confidence interval. So this is like a lower bound and upper bound, but if we're going to put this entire thing together here, I'll add a step 6 actually. But let's take the square root of each of the numbers that we see here, and then we're going to actually find our full confidence interval. All right. So I made this a separate step because it usually is the forgotten step. So we have the square roots of all that stuff. 5, 0, 6, 6, 1, 9, 5, 3. Point 29333 62159. Okay, so let's find out what we get here for each of these. Let's plug that into the calculator. Again, I'm going to take the square root of everything. So in here, so here we're going to round. Now we can round to 4 decimal places here. So we got 0.226, 0. All right, and then we'll take the square root here of 0.29339. So here we get 0.5416. Okay, so our confidence interval here is 0.2260 to 0.5416. Okay, so that's what we have there in step 5. We're almost done here with this question. We do have to do one more step, which I forgot to write in, actually. Let's write that in here. And so the last step here technically is a step that we've done before a few times, but let's at least type it in. Step 6 here is to interpret the interval. Okay, so step 6 here is to interpret the interval. So let's talk about that here in just a second. But before we do, in step 5 here, are there any questions about step 4, step 5? Any questions about that? No. Okay. Want to be sure everybody got the answer that I got here in this case. So, all right. Checks time, nearly 1 a.m. That's a you problem, Connor, not a me problem. No, okay. All right. Okay, so what we're going to look at here next is we're going to take a look here at that again for I guess here. Maybe it's 4:49. Sleep time, Saturday, Sunday. I don't know when you sleep, Connor. You sleep whenever you want, really, at this stage. At this stage, I don't even know if when you go to school anymore. You kind of go to school whenever. That's basically what I've kind of figured. All right. That's right. All right. So let's take a look here at step number 6. How do we interpret this interval? Okay. Now, so what does this reflect here? Now, if we go back to the book question here, the book question talks about the population standard deviation of everything in Tucker County. Okay, that's what we want to find here. So let me go back here to here we go. We go back to our question here in the textbook. This says construct and interpret a 95% confidence interval for the standard deviation of pH rainwater in Tucker County. So what it does basically say is like we're trying to interpret for all pH, the pH of rainwater, all pH of rainwater in Tucker County for like the whole year. If we're taking a look at a sample of 12, we can then extrapolate that to every single one here for say in a given year. As just an example. All right. So what we want to say here in words is we're going to type this out here. Because this is a 95% confidence interval, we can say we are 95% confident that the population standard deviation of all pH rainwater in Tucker County is between. Take care, Connor. You have a wonderful night. Is between 0.2260 and 0.5416. Okay, so that is how we can interpret the confidence interval here. If we're interpreting it again, in this case, once again, we could say the best way to put it is we are blank percent confident that the population standard deviation. So I'll put it this way: we are blank something percent confident, something whatever percentage we are given here, confident that the population standard deviation of all blank, whatever context of all context um, is between blank. Okay, so is between let's go blank and blank. Okay. All right. So if we want a good template here about how to do the interval, again, that's basically how we want to go ahead and plug stuff in. All right. So that is how we can go ahead and solve stuff here with the chi-squared distribution. So it does take a little bit of getting used to because in this case here, as you can see, we had to do things pretty much the good old-fashioned manual way here. But if you follow this same 6 steps, you're going to be able to solve for any one of the answers for any one of the problems here for this particular section. There are not a lot of questions here for this section, mind you, because a lot of times it does take a little time to find those critical values. So again, just please, again, be careful about how we use the critical values. I will go through this video again. If you're not sure how to find those critical values, go through this replay again of this stream here so you can see exactly how I found it on page A15. All right, so you want to be sure on the safe side there. This is how we find it. I had to do that third step first, and then I went to the table after I found those two values. Okay. All right. Any questions about this example? I hope that was Pretty straightforward, question mark. So, no, that works. Okay. All right. Not much for me there. Okay. All right. That's okay. All right. Good stuff. Okay. So that is everything about. Oh, that's why, because that's section 2. I wanted. All right. So that is essentially section 9.3. Pretty much every example is going to fall underneath this type of context and these steps. So again, these steps here should help you out with the most of the rest of the problem. Now, to go along with this, there is section 9.4. Now, section 9.4 is a recap section of everything in chapter 9. And I did actually want to actually show off this recap section here really quickly. The reason is because one of the things that we talk about here is what's the difference between each one of the 3 sections we've talked about confidence intervals about here. So I've broken it down very carefully here for every section about what information is needed and what each confidence interval represents. Okay, so let's take a look at number 4. How do we know which method to use? Because in section 9.4, it just says, okay, here's some random problems. Well, how do I know which one to actually use here in a given situation for which confidence interval? Because they all kind of look the same. You're like, well, construct and interpret a 95% confidence interval, and you're like, do I use the proportion one? Do I use the t-distribution one? Do I use the chi-squared one? Which one of which am I going to use? I don't know. Well, there's certainly going to be some good telltale signs which section that's going to fall under. All right, so in section 9.1, we used a population proportion. And that population proportion here was population proportion P. We also needed an X and an N, okay, so the number of people who said yes and a sample size. We also needed a confidence level, and again, we used a 1 prop Z into there. We used that on our calculator function to go ahead and find the confidence interval in that case. All right. We also had in section 9.1 using formulas to find the necessary sample size to do a conductive study. Like, okay, not a problem. Remember, the interpretation of this is the proportion of blank is between blank and blank. Okay, so that's basically essentially you say blank and blank. All right, so the proportion of something is between blank and blank. That's essentially how we can interpret pretty much everything here. We are confident that we are 95% confident that the proportion of blank, the portion of blank is between blank and blank. So we are blank percent confident. And we are blank percent confident that the, okay, so that's essentially how we can interpret that without any trouble. Section 9.2 uses the t-distribution. Now, what we needed to do is we need to be given a sample size n here to find the degrees of freedom. Okay, again, that was n minus 1, same thing. This uses the t-interval. We can use either stats or a data set. All right, but probably the most important thing here is that in this case here, whatever information that you're given here, you're going to assume that the population standard deviation is unknown. So that's kind of the one dead key giveaways here. Another dead key giveaway is the question that they may ask you in a problem like that. Exactly what exactly is it asking you for? Well, it's asking you to find a compute and say interpret a confidence interval for the population mean of all. So you could say we are, again, we'll just copy and paste this. So We are blank percent confident that the population mean for all context, all right, is between, all right, blank and blank. Okay. So that's another way. In this case here, the more important part here is the population mean for all. That's the big deal here. In this case here is the proportion of, okay, that's kind of like the big deal here. All right, so that's why I've kind of capitalized it. It's like the proportion of, or again, population mean for all. That's the distinct difference between both of those. So it looks like pretty similar. You're like, oh, well, what's the difference? Well, the difference is really in the meaning and what they're asking you. So read the problem very carefully. And if it says, okay, find the mean, find 95% confidence of the mean of all blah, 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 fine. You'll know which one to use. That's the t interval. Finally, it's this last section we just talked about, which was the chi-squared distribution. We needed a sample size. We needed a sample standard deviation. All right. And we needed, again, distributions not symmetric. Again, the interpretation here, as we've just seen here from before, is we are, again, I'll just copy paste here once again. We are blank percent confident. And remember, in our question, in our example, we talked about the population standard deviation. That's what we're trying to interpret, at least in this instance, uh, for all context is between blank and okay. So again, nothing going on here. Sample size, standard deviation. You need degrees of freedom here. I guess I'll add a little bit more to this. Need degrees of freedom, and you need two critical values from the book. All right, so I'll add a little bit more to that. So, but again, that's significantly different, all right, than what we did in the first two parts, where we heavily used functions from the calculator to go ahead and find our confidence intervals. All right, so that should be kind of a dead giveaway here is population standard deviation or population mean or proportion. You'll know which one that kind of categorizes in based on the wording of the question. Okay. So that was a good summary here of everything that we did here in chapter 9. So from a week and a half ago up until now. Okay. Any questions about that? Any questions about anything over chapter 9? That effectively is the end of chapter 9. That was a lot, yes. But um, that was quite a bit for one example. I won't lie. We did quite a bit for those 3 sections, but it was just a brief summary of what we did here for those 3 sections. So I'm just pointing that out there. But I want to give you guys a little bit of time to digest the said material. And of course, there's the test to also think about as well, because of my math lab not being very cooperative. So okay. can we start? Can we start doing examples from the homework for each section? Um, yeah, like what, Natty? Like one question for each section? Well, some sections only have like 5 questions. But if you have an example question you'd like me to go over, I can do that. That's not a problem. Do you have a particular problem you'd like me to do? I don't want to give away the homework questions though. Some of those you have to work on your own. You know, it's practice. But if you give me a question from the homework there, then I can certainly do that. That's perfectly fine. So like, let's see if I can access it first of all, because it's my math lab there. Okay. In reality, I try and match the homework as best as possible. Sometimes they'll go into a little bit more technical detail. Like maybe sometimes you go to say, "Hey, help me solve this," or view an example, and then it gives you all these little extra details that it didn't seem like I talked about. And in which case they're going into much more detail than really what you really needed to know in order to get the problem done. It's kind of more exhaustive in some ways, like I guess is the best way to put it. So, but to be fair, let me see here. Um, okay, so if I went over like today's section here, like section 9.3, for example, if it'll let me go. Oh, there he goes. Okay, so see how there's like 4 questions, right? Oh yeah, I forgot about that. Okay, hang on. My computer's a little strange because I like all right, there we go. We change it to from dark mode to light mode. Dark to light mode. Yay. All right, so some of these are like, for example, here you would have like finding the critical values. All right, so then in this case here, you would use again the back of the book here for this one. So I'm gonna have you. I want you to try this on your own here to find in the back of the book, which is page A15. You have to find the degrees of freedom with the sample size, and of course, with an 80% confidence level, you have to do the alpha over 2, so 1 minus 0.8 and that sort of stuff there. Um, that part there is not too tough. Okay. Okay. So like this one here, let me talk about this one. All right. So I'm actually going to look at this one here because I actually will acknowledge one thing here regarding a question like this sometimes. Sometimes this can happen, and I will certainly admit to it. I'll definitely cop to it here. So this one says a simple random sample of size n is drawn from a population known to be normally distributed. The sample variance, excuse me, the sample variance s squared is determined to be 12.8. Okay, compute parts A through C. Now there's 2 ways to go about doing this here. Okay, it gives you a sample size of 20, and it says to construct a 90% confidence interval. So you need to find of course, your critical values here. So a couple things that you would do for a problem like this here, and parts that can be tricky or may not be tricky, have to be a little careful here. Let's say you had to find your critical values here for this question. Okay. So in this case here, we have a sample size of 20. That means our degrees of freedom here have to be equal to 20 minus 1, which is 19. Okay. We're also given a confidence level here of, in this case here, 90%. So we have a 90% confidence level. So in this instance, we have to do 1 minus 0.9, which is 90%. So that's 0.10. Take that 0.10, we'll divide that by 2. Here we get 0.05. So this is going to be 0.05 here is going to be our alpha over 2. So alpha over 2 here is going to be 0.05. Then we do 1 minus alpha over 2. So that's 1 minus 0.05. 1 minus 5% essentially. That's going to be 95%. So now we have the column here, and now we have the degrees of freedom here, which is 19. We have our two values here we can use for our critical values. So let's take a look at that here. Okay, and we'll see what these lower bounds mean and whatever. So take a look at that. In any case, go ahead and find out what we have here. So, oh, right, need to go back to the book. All right, so where did I put the, all right, here's the text. All right, so I need to go to the e-text here because I need to reference the page here in question. All right, so here's page A15. All right, so we need to reference back to this in order to find our two critical values here. We have to use a textbook here. We're not given a choice. So we have 0.05 and 19 degrees of freedom. So 0.05, 19 degrees of freedom. We'll just line it up. Oop, that's not 19, that's 22. All right, so 19 here, that's going to be 30.144. This will be critical value 1. And then for 0.95, which is over here, for 19 degrees of freedom, 10.117. That will be for critical value number 2. Okay, so we have both of our critical values here. Now it says here in the problem, let's go back to the problem. So like in this particular question, it does ask us here what the lower bound is going to be. Now there is one tricky part to this problem here. The formula here says on our notes, it says, go back for a second here, n minus 1 times s squared over the critical value 1 and critical value 2. All right. Now, let me write that down here, and you'll see why things can be a little bit messy if you're not careful. I'll put critical value, whatever. All right. In this case, using what we have given here, we have our two values. We have 20 minus 1. Now, the tricky part here is s squared. So let me be a little bit more clear about what that means. S squared is actually given to you here as 12.8. So what you actually have here is actually 12.8 straight up as is. Because in this case here, they didn't give you the sample standard deviation. They just gave you what the variance was. They gave you what s squared was. It's just a straight up 12.8. That's it. So that part here, I admit, can be confusing because if you don't read that carefully, things could go in a different direction. Then all you have to do is do the rest of this out, and then you can go ahead and proceed to do. So let's take a gander here at this one. 8.07. I want to see if they did that or not. Yep, okay. Did. So I got 8.07 for that. And then the upper bound here is the same thing, just divided by 10.117. So 24.04 Okay. Okay, so here if we divide by this here. Okay. Now I have to make, you know what? We want to make sure about one thing here. Check that. Should be correct. Uh, yeah, that's right. Okay. Those are the bounds there. Yeah, that's right. Okay. I guess really super technical, but it's important. I guess I'll add one more note to that. Yeah, add one more. That's really super. That's really super. If given s squared lower. Okay. I think that's how it's going to go here. I'm just going to kind of type it in here. It says if given s squared, then just find the lower and upper bound. Okay, so it only applies in only a very rare instances if the variance is just given outright. So okay, we'll have to run with that then. Okay. And then it looks like the rest of these questions here basically runs around the same thing. You have the same critical values here, but then the sample size changes to 30. You change that stuff up there, you'll be able to solve for the remaining parts. So that's pretty much how we can go ahead and approach that. All right, any questions about that? Welcome. All right, good stuff. Nope. All right, so that is where we are going to end off here for today, ladies and gentlemen. That is where we're going to end off here for today. I sincerely apologize about all my math lab issues. I wish that I could fix them in an instant. My math lab looks like it's working a bit faster right now, so maybe it's a good idea to give it a try, or maybe give it another couple hours and then hopefully it'll be completely back to normal. In any case, if you want to get stuff done before that Wednesday deadline, now's your chance. It's probably a good idea while my math lab is working somewhat decently right now. So you may want to get on that ASAP if you don't really have a lot of faith in the current system. All right. In any case, though, yeah, right? And it's kind of wishy-washy, so as we can all agree. So you obviously want to get all those attempts in, and all that practice in as much as possible before it goes kaputski. All right. In the meantime, though, everybody, Thanks again. I love all of you guys. I'm glad I definitely will get to see you guys again here every couple days. We will come back here. Nah, I know. Still though, I gotta make sure you guys are taken care of. So it's important. Um, all right, everybody. Thank you very, very much once again for coming on out here to the stream. You guys are lovely. You guys are wonderful. I love all you guys. Everyone, have yourself a wonderful couple of days. We will be back here, right back here on Wednesday. Okay, on Wednesday. Same time, same place, everybody. All right. Good night. Take care of yourselves. We will see you later, everybody. Have a great one, Natty. Have a great one, Susan. Have a great one, everybody. We'll see you later. Bye.